All right, so what we're going to do is we are going to develop the cosine function similar to that of the sine function so that you can see where it comes from, and then we can use the shortcut. So the first thing we want to remember is we want to remember our baby unit circle, and remembering that on the baby unit circle, the x-coordinate was the cosine value. So we want to take the cosine value, which is the x-curve, the x-coordinate, and that's the one that we want to use to plot our cosine graph. So I'm going to make some straight lines similar to what we did yesterday in class, and we're going to just go out the x distance. And so I'm going horizontal to the x-axis so that we can use the x values, not the y values. We want the x values. So x is horizontal. And so I'm going to take those. And then I'm going to do that for the bottom half too. There's going to be one difference here between this and the sine. And sine was up as positive and down as negative. And cosine is not. Cosine is left as negative. So what I want to do is I want to say, okay, on my baby unit circle, the x-coordinate on the unit circle corresponded to cosine of theta. And that's going to be true still. However, what we want to look at now is this x distance, so from origin to the unit circle in the horizontal direction. So in the quadrant 1, cosine is positive. In quadrant 2, the cosine theta is negative. Quadrant 3, cosine theta is also negative. And in quadrant 4, the cosine of theta is a positive value. So I'm going to take the red lines that I just used, and I'm going to bring them over here, and I'm going to put them on my graph, but keeping in mind that the cosine value, even though it's x, I'm going to plot it as the y value here. So this graph is going to be represented as y is equal to the cosine of theta. So my input is theta. Remember, x is equal to our theta. We're talking about an angle. So the first red line that I see is right here. And remember, this was a positive. So I'm going to go ahead and I'm going to flip this. And I want to flip it so that it is going to be a vertical line. I think I want to. Maybe I can rotate it. All right, I'm just going to rotate it. Flip up, down. That doesn't want to work. Flip left, right. Neither of those is going to work. All right, so I'm just going to grab the end and I'm going to switch it. So we're going to go like that. Okay, so flipping didn't work. And remember, that was at 0. So look at that. At 0, my cosine was 1. Nice. And now I want to take this next line, which remember, this is at 30 degrees, or pi over 6. So at pi over 6, I want to take this, and I just want to swing it around. And I want to bring it over here. And I'm estimating pi over 6 as less than pi over 4. Correct? I'm going to take the next one, which is at pi over 4. And I'm going to flip it so I make it vertical. And I'm going to bring it over here to pi over 4, which is exactly right there. And then I'm going to come to pi over 3. And I'm going to keep doing this. Ooh, no, I'm going to keep doing this. And I'm going to bring that to pi over 3, which is at about right there. Close enough. Remember, these are estimates. So if I'm a little off, it's okay. But now at pi over 2, what's the x-coordinate of this dot right here? Okay, the x-coordinate of this dot is 0. So at 0, so here at pi over 2, my cosine value is 0. Okay, here also, the x-coordinate of this dot is 0. Correct? So the x-coordinate of that dot is 0, negative 1. So the cosine at 3 pi over 2, this cosine, this value is equal to the cosine of 3 pi over 2. That's what that is. So we're going to come to 3 pi over 2, and we're going to put another 0 right there. Okay, so now all of a sudden, remember, I hit quadrant 2, And let me remind you, we said that in quadrant 2, the cosines were negative, and they're negative because they're pointing to the left. So when I bring this red line over here, I want to make sure I rotate it. So we bring it down. And then I want to make sure that I put that at negative. Remember, because it's pointing left. Left is down. So I take the next line, trying to keep it the same length. And I'm going to bring it over here. And that's happening at 3 pi over 4. And then this one, I'm going to rotate it. And then I'm going to bring it, put it down. And then this is, again, this should be at 1. So we're going to bring it over. And I'll adjust it if I need to. No, good. Well done, Miss Collins. Okay. So far, so good. All right, I'm going to pause now, and I'm going to put the rest of the lines in place. You can draw them on yours if you would like. Okay, so now I have all of my red dots moved from my unit circle over to my cosine graph. And now all I want to do is connect the dots. So I'm looking for connecting the dots now. And so dot, 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 dot. So I'm looking at the tips of the lines, just like we did with cosine and sine. And look at that. There we go. And it turns out that if I start at 0 and I go to 2 pi, my cosine is positive, and then I'm negative. I stay negative, so positive, negative, negative, positive. And that's going to keep repeating over and over again. And I can go either left or right around my circle. So notice that if I were to go this way, those values are going to be exactly the same. And then I'm going to come down, and then I'm going to come up, and then I'm going to come up. Notice that the maximum and minimum values are still 1 and -1, just like on the unit circle. Okay, so this is going to become our parent function. So when we look at the information here, we want to keep in mind that our parent function from 0 to 2 pi, halfway is our minimum. Okay, halfway is our minimum. So now we're going to take a look at the general information, and then we want to be able to use the shortcuts to graph a cosine function as easily as we graphed the sine function. So general form looks just like the sine curve, absolutely the same. The only difference is we're talking about the cosine values. So as a quick review, A represents our amplitude. Remember, we use the word height to describe this. This is going to tell us our max and our min height from our zeros, right? So our parent function, we look back, our parent function, this has a height of 1. This height of 1 down. Notice there's a 1 right there. Okay, the second thing is we are going to find our period. And the way we're going to find our period is we're going to take our mother function, which, by the way, in this case, we're going to use the papa function, cosine. And we're going to take 2 pi and we're going to divide it by b. That's going to tell us our period. H is still going to represent a horizontal shift. The horizontal shift means left or right. So we're talking left or right. And remember, inside is opposite. So a plus sign means left and a minus sign means right. And here, the last one, this is going to be our vertical shift. And our vertical shifts are up and down. Okay? Up or down. If it's positive, it's up. If it's negative, it's down. Okay? And we're going to use the same patterns that we used for sine to develop our cosine. Okay? So if you have a graphing calculator, tonight I want you to pull it out and I want you to just practice. Okay? So y equals cosine x. And I want you to compare this parent function. This is the father, or our parent. And now I want you to compare it to something like y equals 2 cosine x. Okay? Then I want you to compare it to something like y equals negative cosine x. I want you to compare it to y equals the cosine of x plus pi over 2 is a good number. And y equals cosine of x minus pi over 2. Okay, and see what happens. Okay, so we're only changing one thing in every one of these graphs, and we just want to look at the pattern. So take some time, play with your calculators, and then come back, because I want to show you one more thing. Okay, you've played with it with your calculator, you've looked at the cosine curve, and I just want to do an example or two where I show you the different kinds of changes. And again, we want to use the shortcut. Okay, so as an example, I'm just going to do a couple. We're going to take a look at this. This is going to tell us that our amplitude is 2. That means our maximum and minimum values would be 2 and negative 2. Okay? This right here is going to tell us in words that we want to shift left. That's what that means. Okay? Shift left because of the plus sign. So I want to know how much I'm going to shift left. So the first thing I should notice inside the parentheses is that there's a 1 connected to x. So I can find the period by taking 2 pi over b, and in this case that's 2 pi over 1, and then my period is 2 pi. And similar to in class today, when we talked about the mother of all functions, cosine has the same period, 0 to 2 pi. And so what we want to do is take the parentheses and we want to put it here, just like the sine curve. Okay, we're going to solve for x. What we do to one part, we do to all parts. And so we end up with x, silly girl, pi, negative pi. Okay, now I want us to think back to the cosine function. The cosine function started up and then went down and back up. So remember, our cosine function starts up and goes down. It looks similar to this. So in your little thinking bubble, you're thinking cosine curve starts up, goes down, and comes back up. Okay, that's what we're thinking. So when we're looking at our key points, we're looking at these points starting at the same place. Well, those are going to be starting at our amplitude. Well, our amplitude is 2, so we want to be able to have those up at 2, at a height of 2. Okay? Now, remember from today in class, these are going to represent our endpoints. These are the endpoints. So the endpoints for this function, and I say endpoints, I use the word endpoints very, very loosely because I'm saying endpoints, I'm talking about the time for one period to occur. All right? So I'm using endpoints so that I don't have to graph an infinite curve. I'm just graphing one period. So at negative pi and pi. So I want to come back to my curve and I want to say, okay, at negative pi, I should be up at 2. And at pi, I should be up at 2. Okay? We want to use shortcuts, and not shortcuts because we don't want to do the work, but shortcuts because we want to save time. We want to work smarter, not harder. So halfway between those, look here, halfway between my endpoints, I bottom out. So let's look at our picture. Halfway between negative pi and pi is 0. At 0, I should be at negative 2. Okay, 0 is at negative 2. The next part requires us to do some thinking, but I've done a nice graph here. When we say halfway, we literally mean halfway. Halfway is a 0. Looking back here, halfways are our zeros. Halfway between is a 0. So we want to come here. Halfway is a 0. So when we say halfway, we're talking halfway between here and here, these 2 points. And it turns out we go like this. This one's kind of tall for my graph, and I'm short, so sorry. That's your cosine graph. The only thing I'm looking for here is that you can tell me the coordinates of the 5 points that we just talked about. And so we want to label those. And you should see pi comma 2. I'm so short. Okay, you should see symmetry here, right? So the midway point, here's my midway point, and look at dot, dot, equidistant. Here to here, they're the same. Here to here, they're the same. And keep in mind, I know your graphing calculators sometimes don't look exactly the same, but here's the important part. This cycle is going to keep repeating. It's going to keep repeating over and over and over again, okay? Over and over again. I'm not expecting you to continue drawing this forever. And by the way, it keeps going, and it keeps going. I'm only expecting you to do one cycle. So in this one, I had 2 changes to my original curve. I had a change in the amplitude, and I had a shift. I did not have a change in the period. Okay, the minute we start changing the period, it starts to look a little uglier, and it does seem harder, but it's totally doable. Let's do one more, and then you'll be good for class tomorrow. Negative cosine of 2x plus. Let's make it ugly. Okay, so that one seems uglier than the last one. And so we want to look at all the changes compared to the parent function. Okay, so the first thing I should notice is there's a minus sign. The second thing I should notice is there's a 2. And the third thing I should notice is there's a shift. Okay, so I should see 3 things different between this curve and my parent curve. So the first thing I should know is that this is going to tell me shift left. Okay, the second thing I should note is a change in my period. And the third thing I should see is a change flip. So flip means what was up is down, and what was down is now up. We're going to follow the same pattern. We want to know what the amplitude is. And that's this number that's right here. Okay? Then we want to take a look at the period. So taking a look at the period, it's 2 pi over b. In our case, that's 2 pi over 2, which is going to be pi. All right, and now rather than worry about the shift and the translation and the reflection and all of that nonsense, I'm going to go over here and I'm going to figure out where are my endpoints. Again, loosely used term endpoints. We're talking about the time for one period, so I'm simply pulling out one period in space. So I want to go from 0 to 2 pi. That's what I'm most familiar with. And I want to go 2x plus pi over 3. Now, just so that I can make this easy for you to see what I'm doing in my head, I'm going to go ahead and I'm going to convert 2 pi to 6 pi over 3 because it's much easier to add equivalent fractions. Okay, this should be an x. That's pretty messy. So I'm going to minus pi over 3 on both sides. And you get negative pi over 3 is less than or equal to 2x, which is less than or equal to 5 pi over 3. Okay, and then I want to take and divide everything by 2. And I get negative pi over 3 times 1/2. That's how you do fractions. Flip and multiply. So I get negative pi over 6 less than equal to. So x is greater than negative pi over 6, but it is less than, we want to do the same thing here. Flip and multiply. Okay, so we get 5 pi over 6. Those become my endpoints. Again, we like the cheating method, shortcuts, if you will. So pi over 6, 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Let's extend my line. 5 pi over 6. Okay, so remember, I'm going to show you this because I want you to understand. The normal parent cosine was up, down, zeros at halfway, minimum at halfway. This is parent. Oops, my bad. Thinking bubble. Thinking bubble. Okay, in our heads. Think. We want you thinking. Okay, so now what I want to do is I want to say, okay, my cosine curve is now not going to be, my cosine curve had an amplitude of 1, but it's flipped. Remember the flip sign. So what was up is going to be down. So it's going to be down here, and it's going to be down here. This is a half. I'll make it big. And what's down here? Boom. Now, what's halfway between this and this? Yes, it's going to be at 2 pi over 6. So at 2 pi over 6, I should be up at 1. Okay? Halfway between these, boom, boom. We'll come back to this dot in a minute. I'm not going to label it today because I want to do that in class tomorrow. Halfway, halfway, right there. And now I just want to connect them. Done. Ta-da! It should look symmetrical. I'm clearly not an artist. Here we go. So our 3 points that I'm going to have you label today are this one. And we said this one was going to be at 3 pi over 6. Oh, my bad, 2 pi over 6. Silly girl. 2 pi over 6, comma, 1. And then over here, we're at 5 pi over 6, comma, negative 1. Okay, these two right here require a little bit of, bigger dot makes it okay, require a little bit of algebra because we're at pi over 6, but I'm only halfway from pi over 6. So half of pi over 6 is actually pi over 12. Okay? So now if I count by pi over 12, 1 pi over 12, 2 pi over 12, 3, 4, 5, 6, 7 pi over 12. And again, I will talk about that one tomorrow. So there's stars here. Stars, okay? I'm not expecting you to do that tonight. Okay, please take a look in your book at the assignment for sine. Just look at them. Talk about sine, talk about cosine. Tomorrow when you come in, we are only going to do graphing of cosine. We'll review this material, and then we'll take our quest. All right? Good luck.